Okay, Assalamualaikum and good day. So, I will continue my lecture for chapter 3 part 2B that will cover about short circuit analysis. Okay, this is the outline for chapter 3 part 2B. So, only 3 subtopic that I will cover for this part B. Okay, equivalent system impedance. Okay, to determine the short circuit current, the total impedance of the system to the fault point must be established. Okay, for common system impedance, there are include of equivalent system, transformer, cables, etc. Okay. All impedance placed before transformer need to be reflected to its low voltage side. Okay, next, short circuit analysis in three-phase system. Okay, since the three-phase fault condition result is in balanced set of short circuit current, the RMS short circuit current at a particular fault point is calculated as this formula. Okay. IRMS is equal to line to neutral voltage. This one is voltage for single phase divided by Z total. So to get the IRMS, we have to get first what is the V in single phase, and then we divide with Z total. The XR ratio is used to determine the instantaneous peak factor and half cycle factor. Okay, this one is in part A. I already explained how to get the factor. And half cycle factor is used to calculate the asymmetrical fault current. Okay, now we go to example 9. Determine the RMS symmetrical, RMS asymmetrical, and peak short circuit magnitudes for a three-phase fault occurring at F1 and F2 for the power system shown in figure below. Okay, the figure is in the next slide. Okay, this is the system. We can see here there are transformer 1 and we have cable here. Okay, and then we have fault occur in this location F1. This one is for A, questions A, and then we have cable here and transformer number 2 and also cable here, and this is the fault location for F2. Okay, next we go to solution. Okay, first we have to calculate. Okay, first step, we have to calculate equivalent system impedance. Okay, this one is at the top of the circuit. Okay, so Z system is equal to this formula. So this formula is referred to as we know, S is equal to V power of 2 divided by Z. So we can get the Z value, Z, by rearrange the formula, we can get the Z is equal to V power of 2 divided by S. Okay, so this is the formula. Okay, next we have to calculate the impedance angle. So theta, as we know, theta is equal to inverse tangent X divided by R. So in the questions already given XR ratio is 3. So to get the theta, we just inverse tangent 3, and then we get the theta here. So then we have to calculate what is the R system and X system. So R is by using the formula R is equal to Z cos theta, and X is equal to Z sin theta. So we insert all the value and we get the R system and X system. Okay, next we have to calculate the equivalent system impedance. Okay, referred to low voltage side of transformer. Okay, this formula already explained in the part 1. Okay, so by using this formula, we can get the RS for low side, refer to low side, and X system for low side. Okay, by using this formula. And then we have to calculate the percentage of R and percentage of X of transformer. This one is step number 2. Okay, this formula already explained in part 1. Okay, you can refer to part 1 for further explanation. So first we have to calculate the theta by tangent and inverse tangent SR ratio. So given in the questions, SR ratio is 5. Okay, and then we get the theta is 78.969, and then we have to calculate what is the percentage of R and percentage of X by using this formula. Okay, so next we have to calculate what is the RTR1 and XTR1. Okay, by referring to this formula. So this is the formula I already explained in part 1. Okay, next step number 3, we have to calculate what is the XR for cable 400 kc mile. So this one also same method as in part 1. We have to refer table to get the R and X value, okay, for these types of cable. And then okay, this is the value referring to the table, and we have to divide by 1000 and times with 50 feet, because in the questions mentioned the length of the cable is 50 feet. And we have to divide by 3, okay, this, because in the questions mentioned there are 3 400 kc mile copper per phase. So we have to divide by 3 to get 1 copper per phase. Okay, lastly we have to get the total impedance to fault at F1. So we know that to fault at F1 there are equivalent system. Okay, this one is the value we have already calculated. And also we have transformer 1 and also cable 400 kc mile, and then we get the total of the impedance. Okay, so by convert this value, rectangular value, to the polar form, we can get the value of Z angle theta. Okay, so we are from the calculator, we just take the value of Z in the polar form, and this is referred to this value Z system. Then we have to calculate what is the SR system. This is to get the SR for the whole system from the source to the F1 fault. So we get the 4.42 value. Okay, so X we refer to this. Okay, this one is for X, and this one is referred to R. Okay, next we have to calculate the RMS symmetrical short circuit current at F1. Okay, to get the IRMS, we have to know what is the V for single phase. So V line to neutral is equal to V3 phase. Okay, V3 phase already mentioned in the questions is 1100. Okay, for the low side. Okay, divide by square root 3. So which is equal to 1100 divided by square root 3. So we get the value here. Okay, 600 35.09 volt. So we divide by Z value. So this one is Z system. So we get the value of I RMS here. And then we have to calculate the instantaneous peak factor. This one by using interpolation. Already explained in the part 2A. So you have to refer to the table to get the value of factor, instantaneous peak factor for 5 and 4, because we know that the XR ratio for this system is 4.42. Okay, we know that XR is equal to 4.42. So we have to refer table 5 and 4, this one, to get the value. And then from the factor, after we get the factor, we can calculate the peak instantaneous current. Okay, I peak is equal to factor times with the I RMS. Okay, so we get the value of I peak for instantaneous current. Okay, next question is for half cycle current. Okay, so first we have to calculate what is the factor. Okay, still using the same method, which is interpolation method. Okay, we get the value of factor for 5 and 4, and then we have to interpolate the value to get the factor for XR ratio 4.42. So we get this value. Okay, and then this factor we have to times with the IRMS to get the IRMS for half cycle. Okay, next is the example 9B. So for B, the method is same as in A, and we have to calculate until we reach the 4FF at F2. Okay, so there are 3 additional items. There are 2 cable and 1 transformer. So first we have to calculate for transformer, this transformer. Okay, get the XR value. So this one. Okay, next we have to calculate for transformer. Okay, this one is for transformer. Okay, we have SR and RTR, transformer number 2. Okay, repeat the same method, and we will get the R and X for transformer 2. Okay, lastly we have to calculate for cable 250 kc mine. Okay, we get the R and X, and we have to refer to transformer number 2 for low voltage side by using this formula. So we get the R and X value. Okay, then to get the total impedance to F2, okay, we have F2 point, so we have to add all the impedance for F1. Okay, this one, add with cable, this one, and add with transformer number 2 and also this cable. So we get the total impedance until point F2 is this value. Then we have to calculate what is the Z. So Z, just by referring to the polar form for rectangular, this one is in rectangular form. So we have to convert into polar form by using the calculator and get the magnitude of Z. So this is the value of Z. Then we have to calculate what is the XR for the system. We get 1.87. Okay, then we have to calculate what is the RMS value. Okay, for this system, we have to refer to transformer for low side, transformer to low side. So the voltage is 415. Okay, in the system, in the diagram 415. So we have to divide by square root 3 to get the value of voltage. So this is the voltage. Okay, but in standard, the 3-phase voltage is 400, but for this example we just refer to the value given, which is 415. Okay, and then we have to calculate what is the factor, instantaneous peak factor, by using interpolation method. So refer to the table to get the value of factor of 2 and 1. Okay, because we know that the SR ratio for this system is 1. Is the value is 1.82, right? So we have to 1.87. Okay, so the SR ratio is equal to, for this system, is equal to 1.87. So we have to refer the value for 1 and 2, and we have to get the value of factor for this SR ratio. Okay, so then after that we have to calculate what is the peak instantaneous current. So the peak instantaneous current is factor times with the IRMS. Okay, so we get the value here. Okay, next we proceed with half cycle. Okay, the value of IRMS for half cycle, still using the same method. First we have to calculate what is the factor for half cycle. Okay, by using interpolation we get this value, and then we have to times with the IRMS to get the IRMS in the half cycle. Okay, next is the exercise number 3. Okay, student have to upload in individual activities in auto platform. Okay, so the question is determine the RMS symmetrical, RMS asymmetrical, and peak short circuit current magnitudes for a single phase line to ground fault occurring at point F1. Okay, this one, point F1 for the power system shown below. Okay, the system will be in the next slide. Okay, this is the single phase system. Okay, we have the equivalent system here. Okay, this one is the equivalent system, and then connect to the transformer, one transformer here. Okay, and then connect with the cable here, and then connect to the second cable here, and this is the point of fault 1. Okay, this is the method. First you have to find what is the equivalent system impedance. Okay, you have to calculate the equivalent system impedance, and also the value impedance reflecting system R and X to the 230 volt. Okay, next for second step, okay, you have to calculate what is the transformer R and X value referred to low voltage side, and then you have to get the Rx for the half winding or single phase. Okay, so to get this value you have to divide by 3 to get in single phase. Okay, third method, okay, you have to calculate the R and X for cable. So there are 2 cable for this system, and for this system there are single phase. So for single phase, the system considered the load current flowing from the source to the load and back to the source. So student have to times with 2 to get the actual R and X. And then step number 4, okay, you have to calculate total impedance to F1. Okay, so you have to put all the Rx value and then get the total amount. Then you have to calculate what is the Z total, okay, by using calculator, and also XR ratio. Okay, step number 5. Okay, last step, you have to calculate what is the RMS symmetrical short circuit current for single phase, and then get the instantaneous peak factor, and also for half cycle RMS factor by referring to the table, and also get the peak value for instantaneous and also peak value for half cycle asymmetrical current. Okay, that's all for chapter 3 part 2. Is that? Thank you.